Hello again. This is the third lecture introducing you to microcomputer and microprocessor. This lecture is about the number systems. Computers are made of semiconductor materials, i.e. electronic circuits. Computers can process data only in binary system because it's easy to represent binary data in two levels electrical signals. A human used to process numbers in decimal system. It is difficult for a human to process or remember numbers in binary. Hence, hexadecimal system is introduced. So, conversions between these three number systems, the decimal, the binary, and the hexadecimal, are important and required. To convert to decimal from any other system, digits weights are used. Each digit in a number has a weight, depends on the radix of the number system. The radix is the number of different digits in a given number system. So for the decimal system, which consists of 0, 1, 2 till 9, has a radix of 10 because the number of digits is 10. The binary system has only two digits, 0 and 1. Hence the radix is 2. For hexadecimal system, the digits are from 0 to 9, which are 10, plus the alphabetical A, B, C, D, E, F. Hence, the number of digits is 16 and the radix is 16. To convert to decimal, the example 504.25 is considered. Then the subscript 10 denotes that the number is in a decimal system. The number digits are 5, 0, 4, then the decimal point, then 2, 5 is the fraction. If we start to the left of the decimal point, we have the number 4. It has a weight of 10 to power 0. Why 10? Because we are dealing with decimal system. The 0 has a weight of 10 to 1. The 5 has a weight of 10 to power 2. And if we have other numbers to the left of 5, will has a weight of 10 to 3, and so on. To the right of the decimal point, we find the number 2, which has a weight of 10 to minus 1, i.e. 1/10. And the 5, the next one is 5, has a weight of 10 to minus 2. If there are other numbers to the right of 5, the weight will be 10 to minus 3, and so on. Now, for the binary numbers, for example, 1001.0011, the 2 denotes that the system is binary. The weights are as follows. The most left number, 1, has a weight of 2 to power 3. The next one, 2 to power 2. The next one, 2 to power 1. And the last one, 2 to power 0. Now, to the right, or the fraction of this binary number, the first number is 0, has a weight of 2 to minus 1, 2 to minus 2, 2 to minus 3, respectively. Why we are using 2? Because the radix of the desired number or system is 2. Now, the hexadecimal number we have an example of 3ab.5f. Of course, the 16 here denotes that the number is in a hexadecimal system. If we start from the point, hexadecimal point, to the left of it, we have b, which is a 16, has a weight of 16 to power 0. Why 16? Because we are dealing with hexadecimal system. The a has a 16 to power 1, the 3 has a 16 power 2, and so on. If we have another numbers, will be 16 to power 3. To the right of the hexadecimal point, we find the number 5. It has a weight of 16 minus 1. And the next one, f, has a weight of 16 to minus 2. If there is other numbers to the right of f, will be 16 to power minus 3 and minus 4 and so on. Now, to convert to decimal system from any other system, we have an example 1101.101 to convert it to the decimal. To convert the binary number, multiply each digit by its weight, then sum them all as shown below. So this number, we start with the most left digit, which is 1, has a weight of 2 to power 3, multiply 1 by 2 to power 3, and sum it with the next digit 1 multiplied by its weight, and sum it with the next digit 0 multiplied by 2 to power 1, and 1 multiplied by its weight. Then we proceed to the fraction number, which is 1 to 2 multiplied by 2 to power minus 1, plus the 0 multiplied by its weight 2 to power minus 2, and finally the 1 multiplied by 2 to power minus 2 to power minus 3. We sum these numbers and find that the equivalent decimal number to the binary number is a 13.625. Another example, to convert the hexadecimal number 1C90.0f. If we want to convert it to its decimal, also sum each number multiplied by its weights. The most left number is 1 multiplied by 16 to power 2, that's its weight, and plus the c multiplied by 16 to power 1, which is its weight, and the plus 9 multiplied by its weight, and the 0, which is the first number in the fraction, multiplied by 16 to power minus 1, and finally the f multiplied by its weight. We have to remember that the C alphabetical digit in hexadecimal has a value of 12, and the F has a value of 50. Finally, we sum all these numbers to find that the equivalent decimal number to the 1C9.0F is this number. Converting from decimal to other system. To convert from decimal to other system, the number to the left of decimal point is divided by the radix of the desired system repeatedly until the quotient of the division result becomes 0. For example, convert the decimal number 16.25 to its binary equivalent. We start with the 16, which is to the left of the decimal point, and divide it by the radix of the desired number, which is 2. The result of the division is 8 and the remainder is 0. Now we take the 8 again and divide it by the radix 2 and find the result is 4 and the remainder is 0. We take the 4 and divide it by 2 also. We find is the result 2 and the remainder 0. Then the 2 is divided by 2. The result is 1 and the remainder 0. And finally, the 1 is divided by 2. We find now the result or the quotient of the division result is 0 and the remainder is 1. To find the equivalent binary number, we have to take the digits from the bottom to the top, i.e. 1, then followed by 0, by 0, by 0, by 4 zeros. Therefore, the 16 in decimal equal to 10000 in binary. That's these digits which are the remainders of the division process. To convert decimal fraction 0.25 to binary fraction, multiply the fraction by the radix of the desired system, which is 2, repeatedly until the resultant fraction becomes 0, as shown. Now, the 0.25 multiplied by the radix, which is 2, we find it is equal 0.50. We take the 0 as the first first digit in the fraction to the right of the decimal point or binary point. Multiply the fraction, which is 50. We don't multiply by 2. We don't multiply this number because we took it to the result. So this 2 multiplied by the 50 will be 1.00. The 1 is taken to be the next digit in the binary fraction. Now we've reached to a 00 in the fraction, so we stop the multiplication process. And therefore the 16.25 will have equivalent of 10000.01 in a binary. Thank you for listening. See you in the next lecture.